Okay, in this section we are solving exponential equations, and at first I want you to see the difference between these two types. With the one on the left, 5 and 125 can be written with like bases. With the one on the right, you have a 5 and a 27. Those don't have anything in common. Like bases cannot be found. Now, based upon those two criteria, that's how you attack these exponential equations. Okay, so here's your first one. I want you to solve 5 to the 3x minus 6 equals 125. The first thing I notice is these can be written with like bases. Okay, and that base is 5. So what you'll see about this one is you have a 5 to the 3x minus 6. And 125 is also 5 to the third power. Okay, 5 cubed is 125. So I can write 125 in terms of base 5. So as soon as you write it with like bases, all you have to do is set the exponents equal. Okay, so if you look at this equation that's before you, 5 to the 3x minus 6 equals 5 to the 3. Well, you know that 5 equals 5, so that's a true statement. So all you have to do is set the exponents equal. So 3x minus 6 equals 3, and we can solve out that baby equation. So I'll add 6 to both sides. So 3x would equal 9, and x would equal 3. And that's how it would work. So if you look at this one, you cannot write 5 and 27 with a common base. So what you want to make sure you do is isolate the exponential expression. Okay, so and that means that 5 to the 3x minus 2, it's all by itself. 5 to the 3x minus 2 is on a side by itself. Okay, the next thing that you want to do is take the natural log of both sides. So I'm going to take the natural log of the left and the natural log of the right. Okay, so I take the natural log of both sides. The next thing it tells you to do is simplify using log properties. Okay, here's what you have to remember. Remember the power rule a couple of sections ago? So what the power rule tells you to do is you can bring this power out in front. So you're going to have 3x minus 2 times the natural log of 5 equals the natural log of 27. Now that puts everything on a level playing field. What we're trying to do is get the x by itself. So right now the x has this family of 3x minus 2. The easiest way to get x by itself is go ahead right now and get rid of the natural log of 5. So see how it's multiplied? You can divide both sides by the natural log of 5. This natural log of 5 right here cancels out. And 3x minus 2 equals some number. Okay, so you have these calculators that you need to use. Remember, it has to be one of your allowed calculators. So you need to enter in the natural log of 27 divided by the natural log of 5. Okay, so you just have to practice until you know how to do it on your particular type of calculator. If you need help, of course, you can always call me. So the natural log of 27 is 3.2958. And the natural log of 5 is 1.6094. So if you divide those out, you get this number, 2.0478, or somewhere in that ballpark. If you're off by a couple of 10,000ths, it's not a big deal at all. So if, like I said, if your digits at the very back are off a little, no problem at all. Now once you get there, all you have to do is solve that baby equation. To get the x by itself, I'll add 2 to both sides. So 3x would equal 4.0478. And then you have to get rid of the 3. So x would equal 1.3493. Hey, I'm not going to trick you on your quizzes or tests with anything that's a rounding issue. So as long as you're really close to 1.35, you're going to be fine with that particular one.